Hello. So, problem 8.12 says that the sides EU and NT of a parallelogram ENTU are 5 units apart as shown. EU is 12, so just this short segment here is 12. EN is 8. So, find the area of the parallelogram ENTU and how far apart are the sides EN and TU. Well, if we think of this line here, kind of like the height from one side to the other. So if EU and NT are the two bases, kind of like how we had it when we have the trapezoids, then this segment would be the height, and the height would be 5. Now, just like we did when we did trapezoid area, if we split the parallelogram into two triangles and find the area of each triangle, we can add them together to get the total area. Well, how can we do that? Well, if I say that the area, let's start with one on triangles, so the area of ETU. That's going to be 1/2. I'm going to say my base of that triangle is 12. So that means that my height is going to be 5, because my height is that distance from the vertex E to the base NT. Oh, I'm sorry. No, I'm thinking of the wrong triangle. So T would be the vertex, and the distance from T to the base EU is 12. And that length here is 5, because it's the same as the height in the diagram. So we have a 5 here. And we have 1/2 of 12 is 6, times 5 is 30. So let's find the area of our other triangle, ENT. Well, that's 1/2. Now, if I really think about it, I know that NT, since we have a parallelogram, opposite sides are the same, so NT is 12. And I can say NT is my base. And then my height must be 5, because it's that same logic we just used earlier. And it ends up being the same, 30. So the area of ENTU is 30 and 30, which is 60. So, very interesting that what this really amounted to was taking the height of our parallelogram and then the base of the parallelograms, EU and NT, and just multiplying them together, 12 times 5. Because if I added these two together, the two separate triangles, the 1/2s would cancel out, because 1/2 and 1/2 is 1. And we're just left with the base times the height. So, with all that said, let's find the distance from the sides EN and TU. So, that distance would be from here to here, EN to TU, making a 90-degree angle, because it's the altitude. Well, when we have the height like that, we should probably think of area again. And we know the area is 60. And we know this segment UT is 8. So what I'm left with is asking myself, well, what could this be could this be to get me the same results in our area? So, when I split up each triangle before, we were left with an area of 30. So if I split up our diagram into two separate triangles, like we just did, and I want the same area. I want each triangle to have an area of 30, because when they come together it has to make 60. So, for example, the area of EUT, I'm going to say my base is UT, and I want to find out what this height is. Well, the area has to end up being 30. And if my base is UT, then that's 8. I'm left with my height. So now I have to find out what my height is. Well, half of 8 is 4. So you have 4h equals 30. And then just divide by 4 to get that the height is 30 over 4, which can be reduced to 15 over 2. And if we do a little bit of arithmetic and like double check that idea we had before, where the area is just the base times the height. If my base is 8 in this case, then 15 times 8 over 2 is the same thing as 15 times 4, which would get me to 60. So, all in all, we have that the area of a parallelogram is the base times the height. And it just depends on the perspective you're thinking of. You can have two different ways of looking at it, where AB would be one of our base and XY would be the height. Or we could say that BC is the base and PQ is the height. It just depends on the way you're looking at the diagram. But either way will get you the same results.